Stoichiometry. It's one of those weird kind of words in chemistry. Even how it's spelled is a little interesting. But what stoichiometry deals with is the quantitative or numerical relationships in a chemical reaction. So, for example, if you were in an industry and you had a certain amount of reactants and you wanted to know how much of the products you should be able to produce, then you would use the mathematical relationships that we're going to learn about in stoichiometry to calculate how much products you would need. Or let's say you need a specific number of products, but you're not sure how much reactants to start with, then you could do a stoichiometry calculation and determine the amount of reactants that you needed to start the process with. So it does have math in it. It's actually very repetitive. Once we get going, there's a very clear plan that you can follow. And so we're just going to investigate it piece by piece. Now, two important things in stoichiometry that are used. One is that you'll be converting between moles and grams. And so to go between moles and grams, remember previously we learned that you would use molar mass. And the molar mass you can calculate from using the periodic table. So if you are having trouble with converting between moles and grams, then you need to go back and review that before you get too far into this chapter. The second thing we'll need to use is a balanced chemical equation. And so you need to be sure that you remember how to balance and what a balanced chemical equation tells us. In my class, for the exam, usually I do give you the balanced chemical equation, in part just because it's easier for me to grade once you get going. Because you'll see if you mess up on the balanced equation, then you will mess up your whole problem. So here's a balanced chemical equation, almost. There needs to be a 3 there. Here's a balanced chemical equation, and it's the reaction between nitrogen and hydrogen to make ammonia. So we learned before on the left-hand side, just recall these are the reactants. And so we can look at a chemical equation and we can see that this has 2 reactants. It has nitrogen and it has hydrogen. And then we can see on the other side of the arrow, these are the products. And NH3 is one of the substances that is called by its common name, and that's ammonia. Now the other thing that we can do is we can use the coefficients from the balanced chemical equation to give a relationship that's very important to us in this chapter. So the coefficients, remember I'm using a highlighter, are these numbers here in the front or before the formulas. And we can relate those numbers to the number of relative moles of each one of our reaction components. So nitrogen, there's no number there, so we know that's, remember we don't write the 1. So I could say that relative in this reaction, 1 mole of nitrogen, and then hydrogen here has a 3. And so that's 3 moles of hydrogen. I just abbreviated mole because I'm getting out of room. And then the ammonia is a 2. So now some of you, as soon as I write numbers, you just associate math and you almost shut down, but I don't want you to do that. Right now I haven't really done anything. I've taken the numbers from the balanced equation, and all I'm doing is relating those to the number of moles. Now, we're going to have to use this idea to create what's called mole ratios. So mole ratios in stoichiometry, mole ratios are used to connect one reaction component to another reaction component. And it could either be relating reactants, relating products, or even relating reactants to products. So just two things in the equation. And every single problem you do in this chapter will rely on the mole ratio. So this is an important idea. Now, a ratio is just simply comparing two things. So looking at our first reaction, and this is the same one I had on the previous slide. If I compare nitrogen, which has a 1 in front of it, to hydrogen, I would just write 1 mole of nitrogen over 3 moles of hydrogen. Now, I could write this with the hydrogen on top. And both of these are considered the ratio between hydrogen and nitrogen. I just flipped it. Now, how we'll know which one that will be required will be based on what we're given in the actual problem we're going to be working on. So then I also could have a relationship that's between two reactants, but I also could have the relationship between the nitrogen and the ammonia. And that's a 1 and a 2. So I could write 1 mole of nitrogen, because a 1 in front of nitrogen has a ratio with 2 moles of ammonia. Or I could flip that. And again, at this point, when we're just talking about ratios, without knowing what else is given, either one of these would be correct. We'll know which one to use based on what we're given when we actually do a problem. Now we also could relate, the last one in this particular one would be relating the reactant hydrogen to the reactant ammonia. I'm going to have to squeeze it down here a little bit, but there's a 3 in front of the hydrogen, so I could say 3 moles of hydrogen, and that would be related to 2 moles of ammonia. Or we can flip that one and put the 2 moles of ammonia over the 3 moles of hydrogen. Now, when we're doing our problems, we're not going to have to write all of these ratios. I just want to give you an example where we just look at each ratio that we could possibly get. The ratio we would use and which one we would put on top and bottom would actually be dependent on what we were given and then also what we were asked to find. So now I'd like you to try to figure out the ratios in the from the balanced chemical equation below between aluminum and oxygen. You can go ahead and pause the video and try to write it down. I'm going to go ahead and write it down so we can see this together. So just going through, I could have a ratio between aluminum and oxygen. And so that's a 4 and a 3. So the ratio is 4 moles of aluminum to 3 moles of oxygen. Or, depending on what I was given, I could write 3 moles of oxygen and then 4 moles of aluminum. Remember, I'm not really doing any math or any calculations. I'm just looking at the numbers that are given in front of the formulas. So I could also compare then aluminum here, which is a 4, to the product, aluminum oxide. So in that case, I'd still have a 4. The 4 will always be in front of aluminum. And then now I have a 2 in front of the aluminum oxide, so I write a 2. Or, remember, you could have it flipped. And put the 4 on the bottom. And in this particular example, and depending on how many reactants and products, you could have way more than just these, or you could even have less than these number of ratios, but these are just based on the reactions we have. So that I could also be asked to compare oxygen, which has a 3 in front of it, to the product aluminum oxide. And so then I would put a 3 in front of the oxygen and the 2 in front of the aluminum oxide. or I could flip it. So take a little bit of time to make sure you understand mole ratios, because as we proceed, mole ratios are going to be used in every single stoichiometry problem we do in this chapter.